Hello, everyone. Nice to see you all here. It's the end of a very, very long day, although there's now one more talk after me, but I appreciate you all staying so far. I'm Noam Honig, I'm from Israel, and I'm going to talk to you today about backend, frontend, and making it all a lot easier. But before I start, I want to get a little bit to know you guys. How many of you do front-end development? Cool. What are you using? React, let's say hands. Okay. Angular? Cool. Vue? Cool. Svelte? Yay! Cool. And what you said? You had something? Drupal? I'm not sure I'm familiar with that. I see. Okay, great. And how many of you know what Vite is, just for clarity? Vite? Okay, good, great. So we'll talk about that a little bit more. So today I'm going to talk to you about writing full stack applications, business applications. That's the focus that I'm going to talk about, but a little bit about who I am. As I said, I'm Noam, I'm from Israel. I'm the founder and CEO of a company called Firefly Migration, but at the end of the day, I'm a developer. I write code every day, and that's what I enjoy doing, both for work and also for fun. I've spent my career working on huge enterprise applications. I've been personally involved in the automatic migration of well over 100 applications, enterprise applications of large organizations in more than 20 countries, applications that are core business or line of business applications in these enterprises and software houses. Things like banking, insurance, CRM, ERP, logistics, manufacturing. Applications with hundreds and thousands of tables, with a lot of business complexity, and that's where I've been earning my living for the last 25 years. As a developer, I consider myself a lazy developer. Okay, I really want to get things done. I don't want to work too hard. I don't want to invest too much effort. I just want things to work. I'm error prone, so I'd like to have tooling to help me handle errors and tooling that will protect me from myself and from all sorts of errors. And I'm what you call a deployment enthusiast, which means I'm impatient. I want to get things in front of my users, if I can, within hours, and if not, within days. So when I come to write the application, the kind of applications that I write have a lot of interactions around data. So usually it's going to be a single page application or a rich browser application, a lot of complex interaction within the browser itself. I've considered using .NET for the backend, as I've been a .NET developer for many years, or Java for the backend, as many of you are. But as I move forward, I figure out that I'm neither a backend developer, nor am I a front-end developer. I am an application developer. I'm focusing on the problems that I need to solve. And as such, using the same language, both for the front end and the back end, is great, because I don't need to do any context switching. I can use the same everything. So I prefer to use TypeScript end-to-end, and usually it's Node.js on the back end. I believe in the simplest possible architecture to get things done. So monolith is a great place to start, and it serves me well in great lengths of projects. Only when the projects become too big, with teams that are too big, I believe in splitting into microservices of all sorts of kind. But for many business applications, start with the simplest architecture you can. I think it makes the most sense. And I would usually use a relational database because I want the database to work for me. So for a certain scale of business applications, that's the stack that I use. So when you come to write a CRUD application, let's break down the acronym. CRUD stands for, does anyone know? Perfect. Create, read, update, delete. Cool. Back long ago, I thought that the CR was for create. I forgot the read, but yeah, great. So when you come to write a CRUD application, a CRUD web application these days, here's what you need to do. You have a Node.js API server, and you have some kind of front-end, React, Angular, Vue, Svelte, whatever you choose. You need to have model types on the back-end and model types on the front-end. You need to have CRUD API route for put, post, delete, to do all the operations, and you need to consume those routes from your front-end and deserialize the JSON and everything around it. You need to have data validations on your API and data validations on your front-end. You need to have access control on the API and authorization queues on the front-end, so users will only see operations that they're allowed to do. You're going to have ORM to interact with the database. You're going to have paging, sorting, and filtering handled on the back-end. You're going to have real-time because you need it, routes and components. That's it. That's all you need to write a CRUD application that does pretty much the basic thing. Sounds reasonable? Sounds horrible? So I struggled a lot with all of this. Been doing this for 25 years, I'm too lazy to do this again and again and again. And when you come to consider this, if you look at these parts, they're pretty much two sides of the same coin. Okay, the model types on the backend match the model types on the front end. The validation on the backend should match the validation on the front end. I find myself with a lot of duplicate code and error-prone code because I fix one end and forget to fix the other. Also, these parts of the code are repetitive. They're all the same. They're just boilerplates are being copied again and again and again. And I really hate boilerplate code because you have those routes for put, post, delete, and then you copy them from one entity to the other with the mistakes, with the security vulnerabilities, try to add. It just becomes maintenance hell. Now, in the recent years, meta frameworks have done amazingly. Things like Nuxt or Next.js or SvelteKit. They allow you to do end-to-end typing with tools such as TRPC, if any of you know them. They allow you to share types on routes between the front end and the back end, but it's just not enough. It's just skimming the top. What I would like to be, I would like to live in a world where I have my single source of truth, my entity, and everything else should be derived from it. Because these are all reflection of a specific business idea. If I have an order, for example, as an entity in my application, the CRUD API routes on the backend and the API calls on the front end reflect that same order. And they should all be defined by that entity. So that's what I believe in, and that's what I'm trying to show you today. So this is a live coding session, which means that's the last slide for now. And this is what I plan to do today. I'm going to have a front-end React application, and I'm going to turn it into a full-stack application, including a database. I'm going to use Postgres. We're going to have real-time live queries. We're going to have validation, authentication, authorization, and hopefully even deploy to the cloud. And that's what I plan for the next 25 minutes, although I have 42, so I'll probably do some more cool things. Sounds reasonable? Cool. So to quote one of the greatest men alive, let's talk about code. So here I have a very basic to-do app. You can add tasks. I can check tasks, but all the state is in the browser, so really doesn't do anything meaningful. And let's review the source code. So this is a React app. And for those of you who don't know React well, I'm going to go step by step. It's not going to be a deep React discussion. But as you can see here, I have the list of tasks. And that's the list of tasks that I have over here. That's my state. I have the add new task functionality. The user inputs a new task. And when they add a task, I add it to the array. That covers this part of the screen. I have set all completed. That serves these two buttons. I have the form for entering a new task, which is the UI for this. And I have the list of maps when I'm able to set completed, set title, or delete a task. Their HTML. And eventually the buttons for setting all completed. Okay, reasonable React app. And I also have a task TS, which represents my type. Every task will have an ID, a title, a completed, and created at. Those are the things I need to know about it. Now, I'm using Vite, and for those of you who don't know what Vite is a React development server, which means that whenever I make a change to the HTML, it will automatically refresh in the browser. So if I'll go to app.ts6 and I don't know, let's make a change. Hello. Okay, it will say hello over here. That's what Vite does. It's a very useful development server, and eventually it bundles the React project into static files that I can place anywhere. So far, so good? Cool. So I want to take this front-end app and turn it into a full-stack app. The first thing I need to do is create a server. So let's start with that. I'm going to go to the source folder, and I'm going to add a backend index.ts. And then I'm going to say export const app. And I'm going to use the standard express library from Node.js, and just say here API/hi, rec res send, hello, Devoxx. Okay? So I have an express server. Now, I would like Vite to also run my Node.js server in development. I like the hot reloading. I like it when I change something, the browser automatically refresh. So to do that, I'm going to go to the Vite config, and I'm going to import Express. Perfect. Cool. So as soon as I do that, if I'll go /API/hi, I will see hello Devoxx. Okay, so I have a very basic API server set up. Cool. Now, here we have the task type, as we've seen before, and it currently resides in the front-end folder. The first thing I want to do is share this type between the front-end and the back-end. There's no point in having two copies of this type. So what I'm going to do is I'm going to add a folder called shared, and I'll drag and drop the type to it. Now, I want this type, which I like to call an entity, to be the single source of truth for the way my database is structured, for the way my API is structured, for my front-end query language. I want everything to be derived from that. And to do that, I'm going to use an open source library called Remalt. So I'm going to say that this is an entity with the key of tasks, and I'm going to ask it to allow all API crowd operations to begin with. Later, we restrict that with authorization, but for now, it's good to start. I'll say that the ID field is a CUID. The title is a string. The completed is a Boolean. And the created at is a created at. So we've defined these decorators over the entity. Now let's go ahead and expose those in the API. So I'm going to head over to our index, and I'm going to say import from Remalt Express. Yeah, I love it when it does that. No, don't go. OK, Remalt Express. I'm going to define API. And in its list of entities, I'm going to set the task entity. OK? That's the class that we've just defined. And I'll say app use API. That tells Express to use Remalt as a middleware. OK? So once I've done that, if previously we only had hi, now I can do tasks, and I'll get an empty tasks array. OK? So just by defining these decorators and doing this one-time server setup, I have full CRUD API routes available to me. Let's go ahead and use them. So I'm going to create a request here. We see that gets return an array, and we can change it to post. And we can say title, test. And it entered a new task to my database. And if I refresh the browser on the right, we see that we have the tasks. Now, some of you may wonder, what database? We haven't defined anything yet. And of course, you can define any database. And later in this demo, we're going to use Postgres. But for this, when you start development, there's a very nice JSON database that we provide by default. It just stores the data as JSON, which is a great place to start. You can play with your data. You don't have to have complex UIs to handle it. So let's go and steal a few tasks from the front end. So I'm going to go here, copy my tasks, and head over to our request, and say here. Great. So now I've entered all of these tasks into my database, and we can refresh over here and see that we have tasks in our database. Cool, so just by defining the entity, registering it on the server, I have a full CRUD API. Now let's go ahead and consume this on the front end. So let's look at the front end right now. Yay. So as you can see, we don't have any tasks, and that's because I've deleted them from the front end. Let's go ahead and grab those tasks from the back end. So what I'm going to do is I'm going to define a task repo, which is a repository of type task. And that repository will handle all of our interaction with the task entity. All the get data, post data, everything around that. Just like you use when you use MongoDB or any ORMs that you want, but I'm using it on the front end to make queries to my backend. So I'm going to add a use effect. Use effect is what happens in React when the component loads. And I'm going to say task repo.find, then set tasks. And as soon as I do that, I get the tasks in my UI. Okay? Notice that I'm using the same task types that I've used on the backend to define the entity. I'm using it now on the front end to query the data. And if we look at the network tab, we can see that it's just a REST API get call. Okay? Now, by default, find goes and gets all the tasks, but that's not functional, so we can do more things with it. Let's say that I want to have the top 2 tasks, or second page. Okay, so this already comes with a built-in server-side paging mechanism. Okay, I didn't need to write any code for it. I can also say here, order by, created at, descending, or ascending. Okay, so server-side sorting. Notice that it's all typed, so if I do, I don't know, some mistake, I'll get a validation error by the tool that I'm using, because it's the same types that is used both on the front end and the back end to query the data. I can also do filter, for example, completed true or false. And that's actually a good time to emphasize that these are all REST API calls. standard REST API calls with the server. There's no mumbo jumbo magic behind the things. It's just simple plain REST API calls. Okay? So true or false, and let's delete the where. Okay, so we got the query part. We got a typed query language that we can use on the front end to interact with the backend. Now let's go and handle the CRUD functionality. We need to create, update, and delete. So we're going to go to the add task, and we're going to say here, await task repo, insert. And we don't actually need all of these because the server will handle that. So if we'll add a new task, we'll get a post call to the backend, okay? And the data is added to our database. And if I want to save changes to a task, I'll go to set completed and say, await task repo save. So if I check any box, we can see that a put request is being sent to the backend. Okay, and this is actually a good time to look at our JSON database because it responds to that. So we can see the true, false refreshes in real time. Okay, let's also add the delete functionality. So now I can delete the test and the new task that I don't need anymore. And again, standard REST API calls. Okay? So again, just by defining the entity, a few decorators, I get a full CRUD capabilities with query language available for me, typed in the front end. Now, my user likes the app. He says, okay, that's great. I want to give it to another user. And the other user got the app and started updating items. And the first user didn't see the changes. Okay? Now, obviously, they need to refresh. We know that because we are developers. But my user doesn't accept that as an answer. He said, but we're looking at the same data. Why can't we see the same data? And that's extremely complex to do. And I think that's one of the things that we try to do with Remalt, is to take something that is complex to implement and simplify the implementation. We didn't develop any crazy technology. We just made it accessible. So let's see what we need to change in our app to make this live query capability. So I'm going to go to our use effect, and instead of find, I'm going to say live query. Instead of then, I'm going to say subscribe. Subscribe gets an infant object that I can use to apply changes. And the last thing I'm doing, I'm going to also return the result. And that way, when the component unmounts, it will unsubscribe. And that's pretty much it. Let's take this here. And you can see that the browsers respond in real time. Okay. Now, this can scale very high. By default, for the development, I'm using server-sent events, but it's just a plugin. You can add WebSockets. You can add industry standard tools such as PubSub or Ably, if you know them. So this can scale very well, but it's simple to implement. And I think that's the game here, because these are repetitive jobs that we do again and again in any of the projects that we work on, and I just hate doing them. I want them done once and done right and done securely, and that's it. Just use them. Okay, so we've done setup, entities, paging, CRUD, live query. Time to talk about validation. Validation is, again, one of those concerns that is annoying when you're developing an app. You obviously secure your API, but then the user gets all sorts of errors. So you create front-end validation, and those rarely match. It's very difficult to keep those both ends of validation in sync with each other. I'd like it to be part of my single source of truth. So let's check out the problem. The user can add empty tasks. That's the user story. So let's protect ourselves against that. So yeah, actually deleted one too many. Let's add the deployment back, so I won't forget. Cool. So let's go to our single source of truth. And I'm going to say for the title that it's required. Okay? And as soon as I do that, if I try to add a new task, I get an error that the title should not be empty. But note the network tab. This is front-end validation. No request was sent to the backend. Okay? Let's try to bypass that and send a post call to our API. So I'm going to go to the request, and I'm going to say here, title empty, and send. And the same validation code runs also on the backend. Now, it doesn't have to be built-in validations. You can write any validations that you want. Any arrow function can be a validator. So I'm going to say here task. If task title length is less than 3, throw arrow to short. And as soon as I do that, if I try to add an item on the front end, I'll get the code running in the front end and performing the validation. And the same code also runs on the backend and validates my API. So I get consistent end-to-end validation by defining it in my one single source of truth. Now, we also made sure that the validation error is structured with every field and the specific error for that field, so you can create amazing UIs where the errors are next to the field, just like users like to have them, and you can do that consistently and easily. Great, so now that the user has validation, he said to me, well, I don't have the patience to set them one at a time. How about you will write a loop that will run on all the tasks and will set them for me? And that's what usually happens. I'm talking to a user, he provides me with a requirement, and since I'm an application developer, it usually starts with some kind of description around the UI. So let's go ahead and implement that. I'm going to head off to our app TS6. I'm going to capture the set all completed function. And I will say here, okay, for task of await task repo find, I'm iterating the repository because maybe I'm just seeing a single page and I want to update all the tasks. And I'll say here, await task repo save of task and completed. Cool, simple change. And let's see, great, everything is set. I'm happy, my user is happy, my boss, not so much. Okay, because my boss looks at the network tab over here and says, are you crazy? Look at how many requests you're making. Imagine if you have 10,000 tasks, this doesn't scale well. Sounds reasonable? Cool. So I'm saying, hey, no problem, I'm using Remalt, I can just move this to the server, it's very easy. Let's do that. So I'm going to go to the shared folder and just create a class for fun. I'll call it test controller. And I'll create a class. Great. And now I'll just copy the function from the code of the UI, from the component, to this class. Now I'll make it static, because that's the syntax on stack, on class, and I'll tag it with the backend method decorator. And the backend method decorator tells Remalt that whenever I call this code on the front end, don't run it on the front end. Make an API call to the backend and run it over there. And just like before, I'm going to define the task repo. Now, previously, the task repo was used on the front end, and for every command that I gave it, it made an API call to the backend. But now when I'm running on the backend, the task repo will do a call to the database. Okay? Cool. Let's register it on our API. So I'm going to go here, add controllers. And in my front end, I'm going to say here, await task controller, set all completed, completed. Great. So as soon as I do that, if I try to set all the tasks, there's a single call on the network tab. So this code is running on the server, and it scales amazingly, and everyone's happy. Now, another benefit that I get from putting this code in the shared folder, from sharing this code between the front end and the back end, is type checking. So if I send the wrong type of parameter over here, TypeScript will protect me against it. It will tell me that this is an error. And as an error-prone developer, this is amazing, because this is the kind of errors that I make all the time and spend hours trying to find. Cool, so let's look at where we are. We've done setup, entities, paging, CRUD, live query, validation, updating, database. Okay, so far we've been playing with our NAS.json database. It has served us well, but it's time to grow up and use a battle-tested database. So let's go ahead and use Postgres. And because I'm using the repository abstraction, I don't care about the underlying database. I can switch it, and my code will continue to work. So if I started with the JSON database, it was great. And now I'll simply import from Remalt Postgres. And I'll tell Remalt that the data provider is a Postgres data provider with a connection string that I've prepared in advance. And as soon as I do that, the task list is empty because I don't have any tasks in my Postgres database. And if we'll check the console, we'll see that it's created a new table for me. Okay, so Remalt comes with a built-in schema ensurer mechanism that by default checks if every table exists. If it doesn't, it creates it. It checks if every column exists. And if it doesn't, it creates it. It never drops a column. It never drops a table. So it's pretty safe to use, and it's forward and backward compatible in terms of migration. But of course, you can disable it and use any migration protocols that you like to use in your organization. So now that I have the data, let's head over to our request. do a few undos and get back our list, and send, and we have data. So entities, paging, CRUD, live validation, updating database. Great. Authentication and authorization. This is, again, one of those topics that gets misused between the front end and the backend. I'm securing the API by the backend team, and the front-end team still leaves the button, and the user gets an annoying forbidden error. I'm sure all of us have had that. And I think that just like anything else, this should exist in my single source of truth. So let's head over to our task. And instead of saying that API CRUD is allowed for everyone, I'm going to say allow authenticated. And that's it. I can't see the data anymore because I'm not authenticated. Okay, now in terms of authentication, you don't need me to reinvent authentication. People have done a much better job than I can. There's a NextAuth, there's a Passport, there's Google, Facebook, GitHub, whatever you like to use. For this demo, I'm going to use a very basic cookie session authentication. So let's go ahead and implement that. I'm going to drop in a snippet that I've prepared, which imports the cookie session and defines it with a very secret. I've defined 2 users in a static list. Of course, in a real project, you'll either get it from an external auth provider, such as Google or anyone, or from a database if you like. And I've opened API entries for sign in, sign out, and current user. And all of those update the user on the session. Okay, now, some of you may ask, why have you used standard Node.js routes and not backend method? And in real projects, I would use backend methods because I like it. But I wanted to show that Rimal fits into your existing stack. You don't have to do an all Rimal project. If you already have an existing project that uses Express or Festify or whatever it is you're using, you can just add Rimal to it and mix and match to get what you need and what you enjoy. So here we have the implementation on the backend. And all I need to do is to tell Rimal how to get the user. So it's going to get it from the request, session, user. Okay, so just like we have the definition of the user here and here, I'm using the same definition to tell Rimal how to extract the user from the session. Cool. Let's head over to our front end, and I'm going to activate the component that I've created in advance. And let's review it. Yay. Cool. So here we have sign in, making a standard fetch call to the routes that we've defined for sign in. And we have sign out and getting the current user, so that just works. So if I sign in as Steve, now I can see my data. Okay? So we've limited the data only to authenticated users by setting this definition over here. And we've hooked it to any authentication mechanism we want. It's just wiring, but we can keep the single source of truth, the definitions over here. Let's make this just a tad more complicated. Let's say that only admins are allowed to insert. Sounds reasonable? So let's go ahead and say here, API insert allowed for admins. And as soon as I do that, Steve cannot add. They'll get a forbidden error. Okay? Let's go ahead and sign out, and let's nominate Jane as an admin. So I'm going to say that Jane is an admin. And if I sign in a Jane, Jane will be able to add a new task. Cool. And let's sign back as Steve. And we can see that Steve still cannot add a task. Now, that's not a very good user experience, okay? Because we hate it when users get forbidden error. I hate getting forbidden errors. So let me show you how I reuse the same definition to provide Steve or to hide the add functionality from Steve. So all I need to do is in my React component, find the correct React component, head over to the form, and say to only show the form if you're a task script or metadata, API insert is allowed. Okay? So only if API insert is allowed, Steve will see the form. And it's all bound to the same definition. So again, if I go to my single source of truth, comment out the rule of API insert, Steve will see the add button. If I'll add it back in, Steve will not see the button. Okay, so we got a consistent behavior around that. Cool? Great. Now, we have actually more times than I've planned, so I have a few questions for you guys. How many of you like to use OpenAPI or Swagger? Okay, that's quite a lot. How many of you like to use GraphQL? Nobody likes GraphQL. Ah, there's a guy back. Okay. Now, everybody likes to use those. Nobody likes to write those. Okay? And this is, again, the idea of using my single source of truth, okay, and deriving from it. You can probably imagine, just like we derive the database and the API, we can just as easily derive the open API structure. So let's go ahead and do that. I'm going to head over to my index, and I'm going to add here open API, and I'm just sending to it the API. You see here. And now if I go to /API/docs, I have Swagger with my API, okay, using the same definitions. And I can do the same for GraphQL. So I'm going to do the GraphQL and GraphQL. And now I'm using the same definition to do GraphQL queries. Okay? I just get those working because you have that existing single source of truth, and you can use it to derive pretty much anything that revolves around it. Cool. Do you like to see this deployed to the cloud? Okay, so let's do that. So before we do that, we just need a bit of preparation. First of all, we need to remember that we've set this secret, so I'll just copy it. And we need to tell it that the connection string is not this one. I'm going to deploy it to a cloud provider called Heroku. Okay? Sorry, not Heroku. I used to deploy to Heroku, but they want money now. So we're going to do something different. We're going to deploy it to Railway. Okay? Railway is a cloud provider from West US, and it's great and have a great developer experience. So let's do that. And Railway sends in the connection string to the database as a database URL environment variable. Okay? And also, so far we've been using Vite to create those, the front end, the React app. Now it's going to be served by a Node.js server, so I need to add functionality here. I'm going to use the same Node.js server to provide me with the React application. So I'm going to say here, serve static files. And basically what I'm saying is that if I'm not in the Vite development environment, please search for the files in the dist folder. When you say build Vite, it will build the static HTML of the React app into the dist folder. And then just our Node.js server will return the files. Cool? Great. Now, the deployment works most of the time, and this is a live demo, so anything will go wrong, but let's give it a shot. So what I'm going to do next, I'm going to do Railway init. It will ask me for a name, and I will say Devoxx PL. And we agreed on the name. Perfect. And then I'm going to do Railway open, and it will open the Railway console in my browser. And then I will ask it to add for me a Postgres database and an empty service. And it spins those up pretty fast. I can then tell it, please give me a URL. And I don't like the URL it gave me, so I'm going to edit it to be Devoxx PL. Yes, great. And I'm going to define environment variables. So the first one we need is the secret. And we're going to go find some online UUID generator and copy it from there. So our secret is secure. Don't tell anyone the code that you see. And I'm going to add a new variable, which is going to be database URL that we'll use to connect to the database. Okay? And the next thing I'm going to do is Railway app. And when I do that, Railway will upload my source code to the server. It will run npm install to install the dependencies that I need. It will run npm build to build everything that I need. And it will run npm start, hopefully, to get this running and working. Now, while we wait for it, let's use the time to do a bit more slides. Sounds like it's been a good lecture there. I expect nothing less of you. Anyhow, Remult fits in your existing stack. You can use it with any frontend, any backend, Express, Fastify, Next, Nuxt, Nest, even Fresh on Dino. You can use it with any database. I've personally worked on projects with all of these databases, and it's very simple to add more database to it, and it can run on any server or serverless Node.js engine. So you can run it on Heroku or Railway like I did now, or on AWS, or even AWS Lambda or Vercel. So it can pretty much run on anything, and it fits your existing stack, so you can start using it today. It's actually battle tested which means it's been used in production applications with thousands and thousands of users for more than 4 years now. So I really recommend that you play with it. There are more things that I didn't get to show you. I actually got to show you GraphQL and OpenAPI, so I'm happy. But there's a lot more controls that you have over it. You have control over lifecycle hooks around the entity when a row is being inserted or deleted. You can intervene and do things. You can control the serialization and deserialization of data between the database, the memory, and the REST API. You can control which fields are visible or updatable. Like, for example, a password will never be shared with the front end, and created at will never be updated by the front end. And you can control that. Of course, if you don't like decorators, that's okay. We like you as well. Just use decoratorless support. And if you don't like TypeScript, you can use JavaScript with JSDoc. Now, hopefully, I bought myself enough time. And we can see here that hopefully the server is ready. And I'm going to ask it to open. Please open. Yes. And we've got the app deployed to production. Now, there's a very important hidden message here, subconscious message. But let's go ahead and try to sign in as Jane. And I'm going to give a task. Pick up the first ever batch of remalt stickers. I'm going to have those for my bag. Great, this is working. Now I'm going to ask you guys to help me test this. So I'm going to create a QR code. I'm going to download it. And I'm going to open it here. Let's make this a bit bigger and zoom in. And I'm going to ask you guys to take out your cameras, read the QR code, sign in as Jane, and wow, somebody was fast enough to check something. So go ahead and do that. I'll take this opportunity to do a selfie with you all because it's fun. Cool. And yeah, it seems like it's working. Cool. So I think it's time for a bit of Q&A. I leave it on for the Q&A. You don't need the slide. You know you're Q&Ing. Yeah. So does anyone have any questions? Hit me. Mm-hmm. 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 So the question was, when we made, I'm just repeating the question for the video. So the question was, when we called the backend, we saw how we was able to reduce multiple network calls to a single backend call, but still on the backend, we made multiple SQLs to interact with the database, and can we aggregate it to a single SQL? So of course you can. You can go all the way down to raw SQL if you want to write your own queries. The default decision in this case was to do that one by one because I want the lifecycle hooks to fit in. So if you have some logic on your saving lifecycle hooks, you still want it to run for each and every entity. But you can, and we plan to do more work on that in future versions to, for example, delete. Most of the time, you just want to delete 10,000 tasks. You don't need to send 10,000 delete documents. So yes, there's a lot of room to improve that, and you can intervene and do that. Cool. Any other questions? Cool. So what I'm going to do next is I'm going to open the last slide of my presentation. And I'm going to invite you all. This QR takes you to remalt.dev. This is our GitHub repo. Of course, it's an open source project. You're welcome to use it and of course, to contribute. We have on our website tutorials on React, Angular, Vue, and Next from 0 to everything that I've shown you right now. Also in a video in English and in Hebrew if any one of you is bored. Please rate our talk on the Devoxx app. And I just wanted to add 2 more things. As I said, this is battle tested and have been tested also from security perspective because it was used in major food distribution efforts during the COVID pandemic. So I got the benefit of having a lot of security checks around this technology. And we have a lot of demos, like you can go and have a CRM demo that shows you how to write a CRM with more than just one table, like a real application with a lot of front end and everything. So thank you very much. I invite you to see this and come over, get some stickers if you want. Thank you.